Hello students. So today we are going to start a new topic which is known as Grignard reagent. So what is a Grignard reagent? It is an organometallic compound. What is organometallic compound? A compound which has carbon and metal bond. That bond is known as organometallic. Now, how does Grignard reagent forms? Whenever we have an alkyl halide, that is reaction react with magnesium in presence of dry ether. It forms RMgX, that is known as Grignard reagent. Now, how let's look the mechanism behind it. First of all, we have magnesium. Magnesium gives 2 electron, Mg plus 2 electron. Second, we have an alkyl halide which accepts 2 electron and which attacks on back of the alkyl group. Then it forms 1 electron attacks backs on the alkyl for R free radical plus X negative. Then R free radical also absorbs 1 electron, then forms R minus. Now when R carbocation take 2 electrons step by step. First is take 1 electron, then R free radical, then 1 electron, then R minus. Now R minus we have here Mg plus 2, and we have dry ether. Dry ether form complex with magnesium like this. It forms complex like this plus R minus. This is a complex which is soluble in ether. So this complex is soluble in ether, or we can say stable in ether, not soluble. Stable in ether. So what happens if we see from in beginning? Magnesium gives 2 electron. Now R negative absorbs 2 electron and form R minus. So what happens to magnesium? Magnesium is stable in that ether. Magnesium is stable in ether, and R minus is forming a complex. Now if we talk about the rate of formation of Grignard reagent, so how good the alkyl halide will leave, that will be the good rate, higher rate, RF, RCl, RBr, then RI. So it has having good rate. This is rate of formation of Grignard reagent. So this is rate of formation of Grignard reagent. Now the question is, why do we use dry ether? If we use moist ether, or aqueous ether, then R minus will react with water, form RH, alkane plus basic solution. So we can say Grignard reagent are stable in dry ether, but in presence of moisture, alkane RH is formed. Alkane is formed. So overall formation is R minus, Mg plus 2 and Cl minus. That's how it's look like how does it forms a Grignard reagent. Now let's talk about its reactive part. So which part of the Grignard reagent reacts? R minus, that is known as carbon ion. Carbon ion can act as a base and it can act as a nucleophile as well. So let's look how does it act as a base. When Grignard reagent act as a base. So what is base? That can extract H plus from, we can say OH, SH, HF, hydrogen fluoride, hydrogen chloride, bromide, iodide, CH, NH, this compound, C double bond O, CH2, this compound. So when hydrogen can, when it can abstract from this compound, so what is, this is called the base. So that is also known as Zerewitinoff's Zerewitinoff reaction. So then that is known as Zerewitinoff reaction. Now let's look some examples, illustration of Zerewitinoff's reaction. First of all, we have CH3OH reacting with CH3 MgCl. Now it will form CH4. Magnesium ClOCH3. How does it form CH4? The CH3 minus from this group reacts with CH3OH and forms CH4 plus CH3O minus. Now CH3O minus forms the one magnesium plus 2 is forming one bond with chlorine and one anion of chlorine and one ion of OCH3. So it is satisfying its bivalency. Now let's do similar type of questions. We have CH3, CH2, SH. Third, we have this compound. All are reacting with, this is reacting with PHMgCl. This is reacting with ETMgBr. Fourth, HI is reacting with CH3 MgCl. Fifth, CH3 C double bond OH reacting with ETMgBr. Sixth, CH3 R C triple bond CH reacting with CH3 MgCl. Now let's pause the video and try to answer by your own. Now let's first of all let's see when it reacts with the PHMgCl, it will form benzene because pH minus will abstract that hydrogen, Zerewitinoff reaction. Then it forms ETS minus Mg plus 2 and Cl minus. Now that's react with an ion, that will form an anion Mg plus 2 and Br minus. It will form ETH. Now third, CH4 plus MgCli. Fifth, this will abstract this hydrogen. We will form CETH, MgBr, Mg plus 2 Br minus and OCH3. Now this will abstract this hydrogen because this is acidic, CH4 plus MgCl C triple bond CH. Now let's look at the seventh reaction. We have CH3 CH double bond CH2 reacting with HBr in case of peroxide. It is forming A and it is reacting with Mg ether. It is forming B. Now what are B is reacting with acid, will form C. Now what are A, B and C? Now try to answer by own. A is anti-Marconic of addition. A will be CH3, CH2 or CH2, Br. B is Grignard reagent. C is Zerewitinoff reaction. MgBr OC double bond O CH3. Now let's solve some more conversions. That's we call conversions. That reacts with Br to H nu. Form A. A will react with Mg ether. Will form B. B will react with phenol. It will form C. Now what is the first reaction? B will react with D2O, deuterium heavy water. It will form C. Now what does A, B and C? A is actually free radical substitution. A is what actually? It will form Br. It will form 2-degree bromide. 2 degrees more stable. This is A. What is B? B is MgBr and C is D. Now look at third. We have toluene. Toluene is reacting with Cl2 in presence of H. It will form A. A will react with magnesium ether. It will form B. So what will happen? And B will react with phenol. It will form C. Now how will solve this? A will actually free radical substitution. It will form CH2Cl. B magnesium diether. It will form Grignard reagent. And C again it will form toluene. With phenol, it will again form toluene plus MgBr OPH. Fourth, this will react with NBS. A. That will react with magnesium ether. B. B will react with this compound will form C. So A will be allylic substitution. We all know NBS do allylic substitution. Then B again it will form Grignard reagent. And C. C it will form CH2. And will form Br minus. Now let's talk about fifth problem. Chlorine react with magnesium tetrahydrofuran. A will form and it will form D2O. React with B2O, B will form. Now when magnesium react with THF, it will form PH MgCl. When will react with D2O, it will form benzene has a deuterium plus MgClOD. Now why we use THF? What is tetrahydrofuran? This is tetrahydrofuran. This has high boiling point because of high molecular mass. So due to this reaction can be carried out at high temperature also. So due to this reaction can be carried out at high temperature also. Now let's look the sixth problem. pH CH double bond CH2 when react with HI it forms A. A react with magnesium ether, it forms B. B react with HI, it forms C. So what is A? Is PH CH CH3I. What is B? B is PH CH minus Mg plus 2I and CH3. And what is C? PH CH2 magnesium and 2 iodine. This is A, this is B, and this is C. Now let's look at the very good problem. Number of Grignard reagent. Number of moles of Grignard reagent per mole of compound. First we have this compound. Now how many moles of Grignard reagent we use? XCH3 MgBr. What is the value of X? Actually 2 methane will form. X value is 2. It is S MgBr. Then it will not react. Now it will form O minus Br minus. Now we don't need to write the reaction, just guess, you have to predict how many moles of Grignard reagents are required. Now here how many Grignard reagents are required? Now let's talk about third molecule. Let's later talk about third molecule. It needs more space. So here 4 molecules of Grignard reagent are required. 1, 2, 3, 4. All these sites are acidic. All these will show Zerewitinoff's reaction. Fourth. Now here how many moles of Grignard reagent we need? 1, 2, 3. And this will react, we need 1 mole. Because this is also acidic. We have RNHH. This will react with base to form RNH minus only. Only one base can be extracted. One H plus can be extracted which form H2O. Not 2 base. It is one, only one H plus will react. So here we have 5 moles. Let's talk about last question. How many moles of Grignard reagent are required? 1, 2, 3. 3 moles of Grignard reagents are required.